Okay, good day, my beautiful students. Let's quickly look into this four thing we have on the board. And the topic is from semiconductor. Remember, we initially started with semiconductor, and we said that semiconductors are those materials that can allow the passage of current or electricity, but under the application of what heat. There is a condition for that. That condition is what? Application of what? Heat. Okay. So in this material, we have two bands, two regions. We call them bands, and these two regions are the one we call conduction band, okay, and the one we call valence band, okay. These are the two bands that we see inside this material. So let me draw it. I have it like this: the first band and the second band, okay. I'm just using this thing to analyze it for you so that you'll be able to understand it. Now, the up here represents conduction band, the up one. That while the down one represents what? The valence band. Okay. So the space between them is called energy gap. We call it energy gap or forbidden region or band gap. Okay, here we have electrons in this valence band. Okay. So here is the conduction band. You can see nothing is there. Okay. Now, Now let's go to intrinsic semiconductor. What is intrinsic semiconductor? When heat is applied to this material called semiconductor, what you will notice there is what these electrons here will gain the heat, will acquire the heat. And when they acquire the heat, you see them moving from that band to another band, from this band to what? Conduction band. I think that is where they will conduct electricity. So when this thing move from here, this electron moves from here to here. Electron is in the conduction band. Remember, we say the flow of charge is what? Electric current. Okay. Now, when this electron is in the conduction band, it is going to leave a space here. Do you understand? Okay. So, how many electrons we have in the conduction band, and how many electrons we have in the what? How many holes we have in the valence band? You can see that the number of electrons in the conduction band is equivalent to the number of holes in the valence band. When this move drifts from here to here, we are left with two holes and two electrons. Okay. So when we say intrinsic semiconductor, it means a semiconductor that the number of electrons we found in the conduction band, when it is equal to the number of holes in the what? Valence band. So we are expecting that the number of electrons in the conduction band is equal to the number of holes in the valence band. Such semiconductor is called intrinsic semiconductor. Here is where we have silicon and what? Silicon and what? Germanium. They are what? Intrinsic semiconductor, pure semiconductor. But if you look at this, if this one move from here to here, it's going to leave three space, three electron. Now, when we come to extrinsic semiconductor, this is when the number of electron is not equal to the number of what? The space. The space is called holes. You can see this space now is called holes. Okay. Now, these are the electrons. Now, this is a case where the number of electrons is not equal to the number of what? Holes. We now have extrinsic semiconductor or impure semiconductor. But the question is, something must have caused that to happen. You understand? Something must have done to the semiconductor for we to achieve that. And that thing is what? We are able to add what we call impurities. Okay? So these semiconductors are added impurities. Okay? So these impurities can transform the number of electrons in the conduction band not being equal to the number of holes in the valence band. So, but these impurities can come from group, either group 5 or they can come from what? Group 3. This group 5 can also be called pentavalent atom. Then group 3 can also be called trivalent atoms. Okay. Now, if you look at if semiconductor is doped with pentavalent atom, which is group 5 elements, something is going to happen. If you look at this, either, okay, when we dope, either electrons are in excess or the holes are in excess. You can see either electrons are bigger than the holes or holes are bigger than what the electron. So, but when we dope with group 5, electrons are going to be bigger than what the holes. Therefore, we are going to consider electrons as the majority carriers, the one bigger than the other one. You understand? Now, why the holes are going to be the minority carriers, and because of electrons are in excess and the electron is considered to be negatively charged, we are going to form a semiconductor we call n-type extrinsic semiconductor. So you can see when you dope with group 5, n-type semiconductor is going to form. Okay, now element that we can find in group 5 are, we can have antimony, we can have phosphorus, and the arsenic. Okay, so we can have what we call antimony, we can have phosphorus, okay, we can have the rest of them. Go and look for elements we find in group 5. Now, if you look at trivalent atom, which is group 3, if semiconductor is doped with group 3, the one that is going to be in excess is going to be holes. So holes is going to be greater than what? The electron. But this one, the electron, the number of electron is going to be greater than what? The number of what? Holes for this one. Okay. So electrons, holes are going to be in excess when you do semiconductor with group 3. So holes are considered to be what? Majority carriers. Okay. So element that we can find in this group 3 are, we can have aluminium and the rest of them. Do you understand? So now, when this group 3 or group 5 are bonding with semiconductors, you can see they are now, you know, joining with what? Semiconductors to form a bond. You understand? And that bond is called what? That is where we have what? Bonding. That bond is called covalent bond. So whenever you come to examination, you are asked a bond that forms semiconductor. Don't waste your time. The bond is what? Covalent bonding. So in the next video, I am going to treat what happens in Band's theory, what happens inside this place, how these electrons are what? Migrating, and how we consider space or holes as positive, consider electrons as what? Negative, and how both of them are the charge carriers. So when we say charge carriers in semiconductor, we have electrons and what? Holes. And electrons are negative charge, holes are what? Positive charge. See you in the next class.